Alrighty, so would Natalie please read today's purpose?
I wanted to identify rocks.
And what's the relevance, Zachary? And Chandler, success.
I will see if my identifications are correct or not.
Okay, so we have 3 different grades you could get today. Next quizzes are going to be not next week, but the following week. I think it's Tuesday and Wednesday. I'm not positive about that, but it's quite a while from now. Any questions on homework that we've covered so far? Selfie, come on down right over there. Okay, main ideas from last lesson. Romeo, read paragraph number 1, please.
Igneous rocks are made when melted rocks cool. If the melted rock is magma below ground, then it will cool slowly. This allows time for large crystals to form. If the melted rock is above ground, then it will cool quickly and small crystals will have time to form.
Austin, number 2. Cindy, number 3. Logan, number 4.
Metamorphic rocks are made when old rock has freed and heated. These 2 processes change the physical structure in the rock, so the rock is.
Parnell, number 5. Wiggly. Next page. Review. Using these word bank questions. What goes in each blank? Number 1, sediments go through 2 processes to make a rock, a sedimentary rock that is. Letter A, compaction, which means to tie, be pressed. Letter B, cementation, which means to be, I'm not going to say it, somebody else has to. Glued. Number 2, sedimentary rocks can be identified by blank of different colored sediments in straight lines, or they can be identified by lots of odd pieces stuck together. Chandler.
Layers.
Layers. Number 3, igneous rocks cool to form patterns of atoms called, back to Chandler.
Crystals.
Yep. Crystals. Large crystals are formed when lava cools, Romeo? Slowly. You have lots of time of it being a liquid, and the atoms can float around in the liquid to be in just the right spot, and then they get captured by the different plus and minus charges, and slowly they build to be larger and larger crystals. Number 5, small crystals are formed when lava quickly. Once the rock cools into a solid, then crystals cannot grow anymore. The atoms are not free to move around and get into the right spots, and so the crystals are not very big. Number 6, lava cools slowly when it is, Chandler?
Above.
Slowly when it's below ground. The dirt above it acts like the insulation of a house or the insulation of a ice cooler. Oh, really?
Yeah.
Oh, look at that. Don't have under either. Okay. Number 7, lava cools quickly when it is above ground or under, not pressure. Madison, underwater. There are underwater volcanoes, and as soon as that lava comes up, it hits that cold water and it goes into a solid form almost immediately. Number 8, metamorphic rock is made when older rocks are put under extreme heat and pressure. Next page. The rock cycle shows how all the different types of rock can change. So once an igneous rock is made, it doesn't necessarily stay an igneous rock all the time. It can turn into these other kinds. Okay, so this diagram is just one way of drawing the rock cycle. There are different ways of doing it. So don't get disturbed if you see a chart where the igneous rock is down here and the metamorphic is up there and stuff like that. The magma is oftentimes in the middle. So I'm going to start off with the magma. You have melted rock. It undergoes cooling, and that turns into igneous rock. We've talked about that before. But the igneous rock doesn't stay rock all the time. It can change in 3 different ways. I could go through some more heating and turn it back into magma. Or, if I don't heat it up quite enough to melt, but I still cook it, heat and maybe even some extra pressure, I can turn the igneous rock into metamorphic rock. I can change the crystals a little bit in order to make different forms of crystals and a different kind of rock. It's not completely melted though. Or I can take this igneous rock and I can break it up into little tiny pieces in a process called weathering. When wind and water and other such things act on the rock, they can break it apart into tiny sand particles and smaller, and those are called sediments. The process is called weathering. A lot of people get confused with erosion here. Erosion is the movement of sediments. The making of sediments is weathering. Okay, so that's how igneous rock can change. Heating, or heat and pressure, or weathering. By this heating, I mean completely turn into liquid. Okay, once we have the sediments, we can compact and cement them together. Compaction and cementation. And turn those tiny sediments into big rocks, called sedimentary rocks. Just as igneous rocks can change by heating, heat and pressure, or weathering, sedimentary rocks can change by the exact same processes. By heating these up, we can turn them into magma again, for instance. We can melt them down. Or, if I don't heat them that much, I can still put some heat and pressure on them and turn their crystal structures into something a little bit different, and it's now a different metamorphic rock. Or I can have wind and rain and water and all sorts of different things. I can have weathering, turn the sedimentary rocks back into sediments. Okay, let's say that we heat and squeeze these sedimentary rocks and turn them into metamorphic. I can turn that metamorphic rock back into magma by heating it, or I can make that metamorphic rock into sediments by weathering. Now you might see some charts that have an arrow from the metamorphic rock back to metamorphic rock. You can squeeze an old metamorphic rock a second or a third time and change the crystal structure even more and change the name again if you really wanted to. Okay, so let's look at some questions about this. This is called the rock cycle. What do metamorphic rocks become before they can be made into sedimentary rocks? Here's metamorphic, here's sedimentary. No matter which way you go, you have to pass through one stage. What stage is it according to these arrows? Sediments. You could go directly from metamorphic to sediments to sedimentary rock, or you could melt them down, then igneous, then sediments, and over here. But no matter which way you go, you have to pass through sediments. Number 11. What do sedimentary rocks have to become before they're made into igneous rocks? Again, there are different routes you can go, but they all pass through at least one of these. Ty. It has to turn into magma. So here's sedimentary rock. We can heat it up, go to magma, and then igneous. Or I could go from sedimentary to metamorphic to magma to igneous. Okay, what's next? 12. How do sedimentary rocks become metamorphic rocks? Heat and pressure. How are igneous rocks similar to metamorphic rocks? They both have crystal structures. By looking at these crystals, we can figure out what kind of rock it is. Is it a crystal made with calcium and oxygen, or is it a crystals made out of silicon and oxygen and carbon, or other such things? You want to identify a rock. Which tool would be best to use? Think about it for a second. Let's have somebody tell me. Ty, what do you think? Yep. Chandler, why do you say that?
Because it just makes the most sense.
Yeah, you want to be able to look at these crystal structures and see what their shape is and what color they are, and magnifying glass would help out the most. What parts are affected by water? There are three different kinds of arrows that are affected by water. Austin, can you name one of them? We're going to write down, first of all, the cooling. If the magma is underwater, it's going to cool a whole lot faster than if it was in air. The cementation is affected by water. If it's really, really dry, you're not going to have the cementation as quick as otherwise. And weathering. A lot of the breaking down of rocks into sediments is done by water of one sort or another. Number 16. Which step would be described as solidification or crystallization? Which one is a synonym or would happen at the same time as solidification? Logan? Cooling. And what steps could be labeled as melting? I didn't use that on purpose here in the diagram. I think it probably would be a better word for it. Zach? How about Sierra? Ben? The heating. Where it just merely says heating here, that is actually referring to melting into liquid magma. Next page. Rock ID project. If you want, we have it on YouTube. You can just watch and observe the things there, or we have the real sticks of rocks in the back, and you'll be answering these questions here accordingly to that.